All right, so I'm on part 3 of this trail that's called Classes and Objects. And again, it shows you the anatomy of a class and how to create and use objects, more on classes, nested classes, and enums. All right, again, some of this you've already seen, some of this you have not seen. This is typically the way in Java, or a way, that you would set up a class. Please look on the screen, because this is what I'm going to show you tomorrow. We have 3 instance variables in here. One called cadence, one called gear, one called speed. And I think for each one of these, we've got a set cadence, a set gear, well, at least those. But quite often what you end up doing is you take one more up to all of these variables that are in here. And each one of these variables that you see there in blue has both a getter and a setter. The getter means return that value. The setter means I want to be able to set that value. So this is what we're going to go through tomorrow. Then if you look, the name of the class, not going to ask, you can look up here and see it. The name of the class is bicycle. Everybody see this right here? It's the name of the class. So this right here, this is referred to as the constructor. The constructor has the same name as the class. So notice, public class bicycle, public bicycle. All right. Here, this says that if I create a new class, what I suppose is you're going to pass in 3 variables. One of these variables will represent the start cadence, one will represent the start speed, one will represent the start gear. Now, hopefully you're listening at least with one ear, but please look up on the screen here. This is the important thing. In Java right here, don't initialize instance variables. That's what the constructor is for. All right, did you hear that? So don't even, well, I'm just going to set them equal to 0. Don't. Just don't. You say, well, give me a really good reason not to. I'll give you the best reason I can not to. They're already set to 0 anyway right there. But you really should be giving them an initial value in the constructor. And that's what they're talking about right here. All right? That's what you're going to see tomorrow when we start going through this, just so you know. All right, and then we talked a little bit about this yesterday. I believe that Evan was the one who brought up the fact, here we got a bicycle class, and here we've got a class, mountain bike, that's extending bicycle. So that's inheritance. He said it's kind of like the using the colon in C#, and it is exactly like using the colon in C#. Not only that, just like C#, Java only supports single inheritance. All right. So as it says, mountain bike inherits all the fields and all the methods of bicycle. Guess what? See that line right there in blue? That's true, yet it's false. And I hate people who talk like that, because then you sound like politicians. All right? But the point is this. Yes, it does inherit all the fields and methods. That's true. But any field that's in the bicycle class, remember it inherited from bicycle, or an extended bicycle? Anything in bicycle class that has been marked as being private, it can't use exactly. So in other words, this class right here, please look at this, because this is about as important as it gets. All right? Up here in our bicycle class, we've got cadence. You can see that. I cannot come into this class right here and put in a line like cadence equals 73. I can't do that. And the reason I can't do that, I can, if I wanted to, I could do it up here, because this is where it's defined. You say, well, it's public. Yeah. When I say you can't do it, what I'm basically getting to is you better not do it, or you're going to end up screwing yourself. How's that? What I'm telling you is, in here, anything that I want to use from in here should be public. You can say, well, these are. That's because that's a stupid example that they put on this trail. Virtually 100% of the time, these will be private. So in other words, if I want to change these in here, I have to call the public methods from in here. Set cadence, set gear, set speed. Does that make sense? All right? Because you got to just, I mean, it's just a rule. You got to do it like that. All right? All right. So to declare a class, it's class followed by the name of the class, and typically before it you put in public, etc. Now, put this on the board, and again, I'm saying this because I want to make sure you get this before we go on. These are all lowercase. This works virtually the same as what we saw last year in C#. If I make something public, anybody and everybody can use it. I've given you this example before, you know, and don't think this the wrong way. I'd never want to have lunch with Trump. But that said, he's a public figure, correct? Technically, he works for me. I'm sure he doesn't think that. But technically, he does. And now, I mean, if I tried to walk into the Oval Office, I'm sure that Secret Service people would arrest me before I got too far. But the point is, what I should be able to do with him being totally public is I should be able to walk in there and say, hey, Don, let's have lunch. You get what I'm saying? Public means accessible to all. All right? On the other hand, before he became president, he was the head of Trump Corporation or whatever the hell that's called. All right? So basically, everybody reported to him. He could see everything that everybody did, and ideally, everybody could see what he was doing, if you were in the company. Does that make sense? When you equate that to software, public means not only is it available within the class, but any other class can use it as well. Private means it's available in the class and only to the class. All right? Now, we talked a little bit about this, where we said if we had, for example, animal, and we had dog, and we had cat, and we had bird, as an example. All right? What if I define something here? I don't care what. Let's just, you know, I'm going to make up something. I'm going to call it hello. So I define something in there that's called hello. And I make it private. All right? That means that I could come in here and change it anywhere in here. All right? But in here, if I've got a method that's called setHello, that's what I use to change that. Does that make sense? All right? But what if I don't want to do that? What if I want to be able to change it anywhere in here and anywhere down here? Except I just want to be able to change it directly. I don't want to have to call a frickin' method. I just want to change it. Then what I do is when I create it up here, I make it protected. If I make it protected, that means it's available not only where it's created, but to any child. Does that make sense? All right. Finally, if you give it nothing, if you don't put in public, if you don't put in protected, if you don't put in private, you put in nothing, then it goes to the default, which means anything in that package that you're working on, remember the package statement? Anything in the package can access it. All right. Typically, unless you've got a really good reason to do so, you probably shouldn't use package access. You're better off with public, private, or protected. All right? Okay. Get rid of that beautiful picture. So that's what they end up talking about in here. Public, private, etc. They're called access modifiers. In this part of the lesson, all they introduce is public and private. But again, they're writing this with the guys that you don't know any programming at all. You guys do. All right? All right. Java methods. If you look up on the screen here, this is an example. I know it's very similar. You could say it's virtually identical to what we learned in C#, but please, just for review or whatever, look at it anyway, because what they say down below here is method declarations have 6 parts. Typically, they have a modifier, public, private, protected, but again, you leave it off, it's the default package. You shouldn't do that. All right? Then they have a return type. Then they have a name. All right? Then they have the parentheses. And you know as well as I do, it's possible when you have these parentheses in here to have nothing. You're not passing anything in. It's also possible for the return type that could be void, which means you aren't returning anything. All right? Now, they don't show it on here yet, but we're going to get into this next week. I'm going to show you how to write your own exceptions in Java. You're going to write those. All right? So you can have in here throws right before this curly brace that's right here in blue. You can have, for example, throws IO exception. So if you've got a program that depends on a file and you can't find the file, you can throw an exception as an example. All right? Then you've got all the method in between curly braces. All right. Didn't we talk yesterday about overloading? Okay, if you look up on the screen here, the stuff that's in blue right now, that's taking the draw method right there. I should just grab it here. And it's been overloaded. Does that make sense? What's different in there every time? What's different? The parameters. And sometimes people think, you know what, all I have to change, I can leave the parameters exactly the same and just change the return type. No, that's not overloaded. All right? You have to change what's in the parameters. What you can do, and I'm going to show you something, don't ever do this. All right, I'm going to grab this, see if I copy it to the clipboard. Hopefully it'll copy okay. Good. All right. I've seen people do this. Now, I'm going to put it here like they've got int I double F. All right. Double F int I. Here's my question for you. Look on the screen. Everybody look at the screen. Is that legal and are they overloaded? The answer is yes and yes. Because what's in the parentheses is different, correct? You know it's the same. No, even if it's just the order, it's different. You shouldn't do that. The word for that is stupid. But it doesn't mean you can't do it. You should not do it. I can't think of a reason for doing that. All right, it says overloaded methods should be used sparingly as they can make code less readable. I don't agree with that at all. All right. Possibly they should be used sparingly, but I don't think they make code less readable. They can make code more understandable. They can make they can augment it more. In other words, they can stretch it, make it do things it couldn't otherwise do. As always, it depends on the situation. All right. Now, does this make sense to everybody? Looking on the screen here, looking at what's in blue. When you go and you create this, 30 becomes the start gear, 0 becomes the cadence, 8 becomes the speed. Does that make sense? There is a mapping that takes place. Now, let's say, for example, I had a string in here, and I didn't want there to be any, so I'm going to do this. All right. So let's see. I'm going to get rid of that line. All right, so I've got this in here. I'm just going to add this. It's kind of a dumb thing to add, but hopefully you'll see why I'm doing it in just a minute. All right, so I'm going to come in here and I'm going to say string name. Again, like I said, kind of a dumb example, but there's a reason I'm showing you this. Okay? If I don't want name to be set, I can just do this. Correct? That's just setting name. And you might say, oh, Jeff, you did it wrong. It's not in order. I'm asking you this question. Does this order here have to be the same as this order here? Does it? No. Why would it? That's like saying if I came in here and I passed in A, B, C, and D, and then in here I wanted to reset A, B, C, and D. Couldn't I reset it in any order? Yes. All right. Now, second most important thing I've told you. I'm going to jump. Where was that? There we go. Not there. Grab this. All right, so I'm creating the class right here. Everybody see this? I'm creating the class right here. So this thing that you see in lines 1 to 5, that's the beginning of the class. All right. Then down here, I'm creating the constructor. All right. What I want to show you is this. I'm asking you this question. Think about it, if you would. Look at what's on the screen. Think about it and tell me if, I'm going to get rid of this stupid thing here, if what I'm about to do is legal or illegal. Is that legal or is that illegal? It is legal, but it's not going to do what you think it's going to do. What it does is it takes this and it puts it right here, which is what you'd want, right? Then it takes this and it also puts it right here. It copies the thing right to itself. So what if I want to keep the same names? Then I've got to do this. See that? So if I want to pass in values that have the exact same name as the variables themselves, and I want to use them, I've got to, where I want to change these, I've got to use the word this. I'm not saying do you understand that. It's just one of those rules that you have to learn. So if you came back and you said, well, what if I just call this cadence X and speed X and gear X? Then do I have to use the this? No. You wouldn't have to. So I could just do this. There are many, many Java programmers who always put the word this before their variables. You don't have to do it, but many people do it. One of the things that you can do in Java, please look on the screen. We talked about this for part of a class period in C#. You may or may not remember it. But notice what it says. You can pass an arbitrary number of arguments to a method. What does that mean? As an example, what if I had a thing that was called setName? All right? I might be able to set up setName where you had to pass in a first name. You have to. But optionally, you can pass in either a middle initial or a last or a middle name, and you optionally can pass in a last name. Are you with me? And the way you do that is you use those 3 dots like are shown right there. That literally says that you can have a variable number of arguments, which are known as, they say here, as var args. All right? Unless you've got a really compelling reason to do this, especially when you're first starting out, that's probably not a thing you're going to want to do a lot. If you were a Java programmer with years and years and years of experience, it might be a different story. All right. We already mentioned this yesterday, but I'm saying it again. If you pass a primitive into a method, you pass it by value, meaning you use a copy. So if you go into there and you change the original value, you're only changing the copy. Once it gets back again, it reverts back to its original value. Does that make sense to everyone? On the other hand, if you pass an object like an array or an array list or a hash or a map, those get passed by value, meaning that any changes that you make, all right, any changes you make are permanent changes. All right, that's pretty much it for classes, so let's change it and talk for a minute about arguments. All right, I've talked about classes, we'll talk about objects. What's an object? Don't read the board. What's an object? 4 words. Instance of a class. Everybody in here were all examples of person objects, correct? All right. These computers are examples of computer objects, etc. As it says, a typical Java program creates many objects. Sometimes it'll have an exact amount. Let's say I'm writing a payroll program, and I know I've got 1,200 people who work at this company. I might create an array of 1,200 employees because I know each one of them gets a paycheck. All right. Sometimes the number of objects you have may or may not be known, or they may vary. All right. This is how you create an object. You do something like this. Does it make sense when you look at what's in blue up here that the first example is going to call a class called point? It's going to pass to a 23 that means one thing, 94 which means another thing. So it's expecting that in the point class there is a method that's in there that accepts and expects 2 integers. Does that make sense? If you look at the rectangle, notice we've got this, it's different. Okay, please look on the screen. Again, this stuff's pretty important. In the first example, you've got 3 parameters. In the second example, you've got 2 parameters. What that means is the constructor for the rectangle class has been overloaded. You can call it one time and pass it 3 things. You can call it another time and pass it 2 things. All right, that's exactly what they're saying right there. When you create an object, you must use the new operator. The only exception to that is if you create an array object and you decide that you want to right away initialize it. You can have the name of the array equals curly brace, your values curly brace. But look on the screen. Do you notice here, in each one of these situations, these are user-defined objects, a point, a rectangle, etc. They've got the variable type followed by the object name equals new followed by the class name followed by whatever parameters that it requires. Does what's up there make sense? Right below it they mention the declaration. All right, that's point origin 1 for the first one. The instantiation, that's new. The initialization, that's point, parenthesis 23, comma, 94, parenthesis. All right. I'm expecting as we go on that makes sense to you because no one asked. All right, again, you all know this. When you use the new operator, you're instancing or instantiating a class. All right, nothing new there. How do you use an object? Look on the screen. You put the name of the object, dot, the name of the variable, or the name of the object, dot, the name of the method. All right, so what are we doing here? We're printing out the width of the rectangle. We're printing out the height of the rectangle. All right? What you're oftentimes going to see, just so I want you to make sure you know this. All right? If we put this out here just exactly like they have it, I'm going to put this over 2 lines, or a blank line between it. This supposes that that's set and that's set. Does that make sense to everybody? What if I hadn't put any value in at all for width or height yet? What if they were null? The program would blow up. Does that make sense? So you don't often see it done like this. More often you see it done like this. This is the stuff you're going to be writing in a couple days. And what that says is go out to the rectangle class and for this object, get its width. That way, if it hasn't been set, you have to provide in your code. It says if it's not set, then default it to 0 or whatever. All right? What this does, what you see on the screen, what that does is it makes sure you never get what's referred to as stale data. All right, like stale bread or whatever. You're making sure that the value that you are getting back is the latest and greatest. We talked already about the garbage collector. I already gave you my own little take on it, where I likened it to the person who drives around to give you a possible ticket for parking too long in a zone and putting that chalk line under it. That's pretty much what they're talking about here. They don't use that example, but it's pretty much the same thing. All right. More on classes. So now they talk about returning a value from a method. Again, pretty much the same thing that we covered in C#, but if you look on the screen, a method returns to whatever called it when one of 3 things happens. Number 1, it reaches the end. So you've got just a return colon in there, or semicolon. Number 2, it reaches a return statement somewhere in there. Or number 3, which we haven't talked about yet, it throws an exception. That's never a good thing. All right, something bad happened and you're handling it. All right, look at the example right here in blue. This should, 2 things in here should jump out to you to make sense. All right, number 1, width must be an integer. Number 2, height must be an integer. Why? Because you're multiplying one by the other and you're returning an int. So if those are anything other than ints, it could be problematic for the program. If you made them floats, it would blow up. If you made them strings, it would blow up. Does that make sense? Just so you're aware of this, you can return an entire class. You can literally create a class and a method and return that class. So what you put in here, that can be void, or it can be one of the 8 primitive values we have: short, long, int, byte, float, double, boolean, or char, or it can be either a Java class or one of your own classes. The this keyword, all right, pretty much what we talked about before. The most common reason for using the this keyword is because a field is shadowed by a method or constructor parameter. Notice again, here there's X and here there's Y. Again, look on the screen. Our variables are called X and Y. Here, we're passing them in as A and B. Not a problem. No problem. We don't need to use the word this. Works just fine. But if we'd done it and declared them up here with X and Y and tried using X, Y here, you must use the word this. And you might raise your hand and go, I get it. Then why the hell would you ever do this? Why? All right, because some people like to use the same variable names throughout. Java does allow you the ability to do that, but you have to follow their rules. All right? The other way you could do it, please look on the screen because this is confusing. You can use this with a constructor. It says from within a constructor, you can use this to call another constructor in the same class. All right, what the hell does that mean? That means what's going to happen is, notice right here, if you create a rectangle and that rectangle has nothing passed in, does that make sense? That's called our no-arg constructor because there are no parameters. Then what that's going to do is it's going to set these things. Does that make sense? It's basically going to set these things that are in here, it's going to set them to 0, 0, 1, and 1. All right? Here, if we call it, we pass in two things, it's going to set the first two to 0, that width to that width, that height to that height. All right? And it, like I said, it's confusing. But these are overloaded constructors. Here's one with no parameters, one with 2 parameters, one with 4 parameters. So they're saying that's a way you can do it. This is my take. You're learning this stuff, right? I wouldn't do it that way. You can have one constructor call another constructor. Okay, what's the advantage? It actually is going to run faster. What's the disadvantage? If you're just learning it, it can be very confusing. So I wouldn't do it like that. I do it the way that I'm going to show you in the examples that we're going to be going through shortly. All right? Controlling access to members of a class, public, private, protected. They call it package private. All right, I called it default. All right, that's the way I was taught. Here is the table that shows this. Notice that if it's public, everybody in the world can look at it. Does that make sense? It's available to all. Then notice protected. It's available to everybody, but not the world. So imagine that you gave a party, and the only people who could come were you and any of your descendants. Does that make sense? You, your kids, their kids, etc. But nobody else. That's protected. All right? Private, you can come, maybe your family, and nobody else. Maybe it's just you, depending on how it's set up. And no modifier means it's available to that class and to that package. But by default, not to anybody else. All right? When in doubt, make it private. Did you hear that? Why? Because you're protecting yourselves. That's not meant to be a funny joke based on that. But if you're in doubt, you make it private. All right? Class variables, we talked about this before. And instance variables, so if I make a class, I'm not going to do this. I'm not going to write it down. I'm not going to put it on the board or anything. We talked about this the other day. If I make a class called person and I put in their height, weight, eye color, and hair color, then I make 5 person objects. I make an Evan person object, a Matt person object, a Devin person object, a Tony person object, and an Andrew person object. All right, I make those 5 objects. Each one of those could conceivably have a different eye color, hair color, height, and weight. Why? Because those are the instance variables. All right? If you've got variables you want to share, like I said, like a person counter, you make it static. So anything that's not static is instance. If it is static, it's class. Does everybody have that? All right. One more key thing about this before we go on is the word final. You know how to use final. We talked about it like for const. You can also, if you take a method and you make the method final, All right, don't look, but please listen. If you create a method and you put final before that method cannot be overloaded. All right, it's basically in its final form. If you take a class and you make it final, the class cannot be extended. All right, think long and hard before doing any one of those. Because what you're saying is nobody will ever want to go any further with this, which may be true now and may not be true in the future, for example. Initializing fields, I mentioned this to you before, that when you create class variables and instance variables, they are automatically initialized. So numerics are automatically initialized to 0. Chars or characters to basically a blank space. Strings to the empty string. Booleans to false. All right? You can also have what's called a static initialization block. For right now, with where we are in here, I wouldn't even go any further with that. You're probably not going to use it until you have some more experience under your belts. All right? So again, there are some questions here again, all right, and you will be doing those. Some more questions, some on classes, some on objects. All right. Almost done with this section. Let's finish this, then we'll take a break. Next are nested classes. What do you think a nested class is? A class inside of a class. All right. If you put a class inside of a class, all right, again, don't look but listen. If you put a class inside of a class, the inner class, virtually 100% of the time, must be private. Did you hear that? Especially if the outer class is public, you can only have, in fact, I think it always has to be private. Sometimes it makes a lot of sense to put a class within a class, especially if it's a little class doing one thing. Sometimes it makes no sense to do it. So why use it? It's a way of logically using classes and grouping them together if they're only used in one place. Number 2, it further increases encapsulation. Number 3, it can lead to more readable and maintainable code. All right? They give you an example. I'll let you look at that. We will actually get into nested classes when we get into the Android part of the class. All right? And I do believe that when we get to that point, you'll be, oh, that makes sense. All right? You can also declare not just inner classes, but you can create an anonymous class. What do you think an anonymous class would be? Anybody want to guess what an anonymous class might be? It's basically, that's what it is. All right, so here's an example right here. It says, consider the instantiation of this French greeting object. All right. There it is right there. Okay. And it's a little quirky. Again, it's a fairly complex topic that I'm not going to talk about anymore. All right. I don't think we're ever going to use it even in the Java, in the Android part of the class. All right. Remember these from last semester? Remember those? We did Lambda expressions where you said like P and then you had like a equal greater than sign, and I know you weren't in there, but what it's basically saying is if we look at an example here, I think they've got them on the next page. There. All right, if you look up on the screen here, it's not that different from what you learned last semester in the ASP.NET class. This is saying, what do I want P to hold? I want P right here to hold a male gender and an age and, well, we're saying and an age between 18 and 25 and an email address. All right? Most people, when they see that, they're like, I get it, but why would you want to do that? Because it can make a program work a lot faster to use a Lambda expression. All right? I would tell you that it leads to code that's easier to read, but when you're first learning about it, it seems like it's a lot harder to read. All right? I don't know what, if anything, we'll be doing with Lambda expressions. All right? But there is an example right there. The author does a good job in here of explaining everything that's in there and how it's used. So if you didn't like my explanation, you can take a look at that one. If we jump down to next, they have in here when to use these things. Again, at the end of the chapter, you're given some questions. But let's pretend for a second it's June, beginning of June. All right? And Matt gets a call. He doesn't have a job yet, but he gets a call to interview for a position as a Java programmer. He thinks, yeah, I think I could do that. It's entry level, etc. This would be the kind of page you'd want to look at. All right? Why? Because they may very well ask you what a nested class is. Chances are fairly good, if they're going to give you a test, an actual programming test, and it's going to be an hour long, it'll be mostly basic, but they can ask you very technical questions. In fact, I think I removed it. I got my counterpart, Evan, in St. Louis, he sent me an email the other day. No, I don't have it. He sent me an email and he said, are any of your December grads still looking for a job or anybody else? Well, we all know that Mr. Fugner at least was looking for a job. All right. So what I did was I sent it over to him. Long story short, he said, this looks really good. It sounds interesting. I'm going to apply tonight. And that's good. Do you remember those 4 of you who were here last semester, how he set that thing out to that bullhorn or whatever the hell it was called? They got a hold of him. They want to do a video interview with him. I don't know how they're doing that. I don't know if that means, I didn't ask him. I don't know if that means he's going to be in there. I don't know if that means that they're going to provide some kind of a camera for him or what they're doing. All right. The point is this. There's a good chance if they're going to interview him for about an hour, they're not going to ask him real technical questions. They're not going to say, how would you write the code to do this? But they very well could ask him a question. Hey, this is for a Java programming position. What is a nested Java class? Tell me what you know about it. Does that make sense? So this is the kind of page you should look through if you plan on ever going for a job as a Java programmer. All right, and the last thing that's mentioned in here after the questions is they talk about enums. We've talked about enums before. A couple quick things about enums. Look on the screen, please. An enum is a user-defined data type. What's the name of the new data type? Day. What are its values? You don't have to read them off. You can see them, correct? Almost always those values are put in there as uppercase. What does uppercase imply? They're constants. Now, last thing, because this isn't in here. Look on the screen. These things are actually names, right? But they're names, but this is actually got a value of 0, 1, 2, 3, 4, 5, and 6. Does that make sense? Because if you want to, and I believe you can do it in Java also, I'd have to write a program to find out for sure, but to my knowledge, you can do this. Why might I want to do that? Look on the screen. Why might I want to do that? Yeah, but so does this. They both do that. So why would I want to do this? Because Sunday is 1 now. It's day 1. It's not day 0. Not only that, you can't, now it wouldn't make sense in this example, but I could do this. Now Sunday is 1, Monday is 2, Tuesday is 3, Wednesday is 4, Thursday is 5, Friday is 37. What's Saturday? No. Yes. So you can do that. There may be a very valid reason for doing that. All right? All right, then there's some questions again. The next thing that's in here is on annotations. All right? And I'll tell you what, look at see how short it is? We could probably do this in 5 or 10 minutes, then I'll be done talking for today. All right? Rather than have you leave for 15 minutes and then talk for 15 minutes. Probably won't even take that long. All right? Back in the day, when I started teaching this stuff, these are what we used for annotations. We use things like this. And I do this. Then if I had it, I'm making this up here. So if I had something like this, so if I had you've seen this type of example before, so I'm just going to make it real simple. Then back in the day, you would write annotations that look like this. Oops. Now you might look at that and go, okay, fine. Who the hell cares? All right. Why would you want to do that? Because if you put in these kinds of annotations, these are the simple kind. If you put these kind of annotations in, then you have to compile the program and you have to put a different, well, you get to say like -m or something like that. I don't remember what it is. All right, but if you do that, then you get this stuff. It writes this kind of stuff out for you. This is the bad example, but it will actually show you there in the detail. You can put in there, you can have it write this kind of stuff. All right, do you see where that might be helpful? That if somebody, it writes this as an HTML file when you put in those kinds of annotations. All right, now that's the way that you used to do it. Now let's very quickly talk about more how it's done today. All right, I'm not saying those aren't still used, but not like they used to be. So it starts with an @ sign. This is, note this one. When we get to the, look on the screen please, because when we get to the Android stuff, you're going to be using this. When you want to do an override, you say @override. When you are working in Android, you do say that. All right, you can say it in regular Java, but typically people don't. All right, the @author I already showed you. You can put in more information than what I showed you. The other things that are important in here is this one. What do you think that does? It says if you have any warnings, don't show them to me. All right, you might want to put something like that out so that if your program ever blows up, the person running the program won't see the error information. You don't want, because it might be database information or something else. You don't want to show that. So don't show the warnings. All right. So they show some places where you can use annotations. The idea behind an annotation is it's showing you more information than you would have otherwise. All right? Here's how to declare it. I showed you a little bit of that already. We're not going to do much work with annotations, but the rest of the chapter is they show you what's in here. Notice this, at deprecated. As it says, it indicates that the marked element is deprecated and no longer should be used. Do you remember when we talked about deprecated tags in HTML? All right. If you don't, remember this. All right. Notice that some of these in here are red. See that? That means they've been deprecated. All right. What does deprecated mean? It means it's still around, it's still out there, but if you do anything new, you shouldn't use it. I asked a class once, what does deprecated mean? Somebody answered, said, we're all deprecated. So what does that mean? He said, well, all eventually we won't be here anymore. Yeah, I guess that's true, but that's not really what deprecated means. Deprecated means it shouldn't be used anymore, and it should eventually go away. Do you really think that if you've got a website that's got a base font in it, all right, that's been around for 20 years and is working great, do you think people are going to pull that out and change it to CSS because of this? I sure as hell don't. But they're saying new development should not include that. Now, if you go in, remember when we did validation on web pages? If you do a validation, you've got base font, it may fail because the tag has been deprecated. All right, the override I already mentioned to you. The suppress warnings I already mentioned to you. All right, there's also a couple more here. There's safe var args, functional interface, and there's some other ones, retention, documented, and target, etc. All right, we're not going to do any work with any of those. I'm just telling you right now. All right. It says there are some situations where you might want to apply the same annotation over and over again, so there are what are called repeating annotations, and they show you how to create those. All right. So again, you've got some questions here, but the answers come right after them. So looking at our trail here, we've now done part 1, object-oriented programming concepts, part 2, language basics, part 3, classes and objects, and part 4, annotations. All right? The rest of the period will be lab for you to work on the stuff. Do you have enough to do right now with the stuff I've given you? All right. So to work on those, tomorrow we will be going over an example that's, for lack of better words, this payroll program in pure Java. All right? And we'll go and we'll create objects. All right? Some payroll person objects. I call them payroll. You might disagree and say you really should have called them employee. Who gives a darn? All right? Then we'll look at it and how we use that in an array instead of just creating objects. We'll do that then on Friday. Or if there's time, we'll do that tomorrow. And then on Friday, I'll give you that pretest. All right? I got to find it, but I've got it someplace. All right? And I'll give you a couple hours to work on it, and then I will go over it with you. All right? I'll show you what I did. I'm not going to give you a hard copy or anything of what I did, but if you understand what's on the pretest, then if we take a test, whether it's Monday or Tuesday, you really shouldn't have a lot of problems with the test. Then next week, we will do 3 things. Number 1, 4 things. We will take the first test. Number 2, we will go over parts 5, which is on interfaces and inheritance. Part 6, numbers and strings. Part 7, generics, which we'll spend 10 minutes on. And part 8, packages. We'll do that. We'll go write a couple more programs as a class, and then we'll take another test. We probably won't take that test until the following week. Maybe we'll have a test next Monday and the following Monday. All right, well, we don't have class that day. That's the 21st. So the 22nd would probably be your second test. Then on the 23rd, we'd start, and the way I'm going to introduce the Android stuff to you is at first, the first thing we're going to do is we're going to write the application in the first chapter of the book, but I'm going to ask that you not even open your books. We're just going to walk through it super slow. If we do it in one period, okay. If it takes 2 periods, okay. I don't care. But I want to do it really slow so you understand the stuff that's in there. All right? There are about 18 chapters in the book. Mr. Smith has a tendency, because I think that he goes through things faster than I do, and I'm not saying that to criticize him, not at all. All right? Maybe his students get it better because maybe he presents it better. I don't know. But I've got to talk to him and see if he's going over every chapter of the book. I don't see how we're going to have time, because now we'll be down to 14 weeks. And I don't know how we can go over 18 chapters and do a good job of all 18. I know what I'd like to go through. All right, there's a couple things in the middle of the book I think we can skip. But I'd like to get into databases, etc. I'd also like to have it set up so that at least 2 days a week, once we get into this and we've got a few chapters under our belt, at least 2 days a week, maybe it'll be Thursday and Friday, I don't know. On those days, you'll have time to be working on your own Android app that you're going to present on Wednesday, May 8th. Any questions? All right. You two can take your break now.
Mr. Howard.